In this lesson, we're going to talk about area. Area is the two-dimensional analog to length. Basically, if you look at any sort of surface, area will measure how much space is being filled up on that surface. We have a few common units for area. Square feet is one that we often use to measure, say, the floor space of an office, a warehouse, a home, different things like that. In metric countries, we often use square meters, and you'll find later the difference between a square foot and a square meter is a factor of basically 10. So square meter numbers look much smaller than square foot numbers. If we need to measure smaller objects in their areas, we'll often use square inches or perhaps square centimeters. One thing you might notice here, though, is that all of these were square units. The question I ask is, are all area measurements square units? Just think about that and come back to it. We'll talk about it a little bit later in the video. Here's a few basic formulas for the area of various objects. For a square, you simply square the side length. That's actually where the term squared comes from when you say the exponent of 2. For a rectangle, you simply take the length times the width. For a parallelogram, you must define the height to be a perpendicular distance between two parallel sides, and the base is the length of the side of which that height is perpendicular. Under that idea, the parallelogram is base times height. Just a little explanation. If you were to cut this area off and move it over here, you'd see this becomes a rectangle with base b and height h. Using the length times width formula, you see that area actually works. For a circle, we just say for the circle, it's pi r squared for the area. That one's kind of difficult to prove in general. For a triangle, we say 1/2 base times height. Now the height is defined similarly to a trapezoid, but the question I bring up is, why does the formula resemble a parallelogram so much? Here's the idea. If I were to make a copy of the triangle by basically taking, say, this point right here and rotating the triangle around it, I would get two triangles that together make up a parallelogram with base b and height h. So therefore the area is half of that. Then finally the trapezoid. The trapezoid has an odd area formula, but basically you take 1/2 of the sum of the two bases, which is actually the average. It's this length right here. That's what the 1/2 little b plus big B is. It's the average length. It's the length of sort of the mid-segment. And we multiply that by h. The reason this works is if you consider taking this triangle and flipping it up to here, and this little triangle and flipping it up to here, you'll notice we get a rectangle with height h and base this length right here. Let's do a few examples. Find the area of a triangle with base 4 centimeters and height 5 centimeters. So let me just draw an example triangle like that. Say the base is 4 centimeters and the height needs to be perpendicular here and be 5 centimeters. The formula for the area of a triangle is just 1/2 base times height. So we do 1/2, then the base is 4, the height is 5, and this is easy enough to say that answer is 10. Now make sure that you put the right units on this. Officially, we multiplied centimeters and centimeters, so we get centimeters squared. And generally speaking, when you calculate area in this manner, you'll always end up with a square unit. Find the area of a circle with diameter 4 meters. Remember from the last lesson, when a circle has a diameter given, that's the distance across the whole circle. So if the diameter is 4 meters, we can draw it in like this. Now the formula we have for area is pi r squared. This poses a small problem to us because the radius is not given. However, remember that the diameter is twice the radius. So every time you're given diameter, you just divide that number by 2, and that'll tell you the new radius. 4 divided by 2 is 2. And now we can finish. Pi is about 3.14. And just like I mentioned in the last lesson, if you use the pi key on your calculator, you'll get a little bit better answer, and it might be the answer that you need in order to get the answer right on an online homework system. Anyway, then we have the radius is 2 squared, and that gives me 12.56 meters squared. Remember, it's a square unit for all area. Find the area of a square with side length 3.5 inches. First thing I want to do is convert that to 3.5 inches. Remember the technique I showed you last time? That if you want to convert a fraction, you simply take the numerator divided by the denominator and then add the whole part. And that'll give you a square with your side length of 3.5 inches. Now to find the area is just one side length squared. So the side length was 3.5, and if we square that, we get 12.25 inches squared. Next example, find the area of a rectangle with length 2 meters and height 5 meters. So here's a picture of what we're looking at. And this one's very straightforward. The area of a rectangle is just the length times width. The length is 2 meters. The height is 5 meters. So we get 10 meters squared. Next example. Area of a trapezoid with parallel bases 8 feet and 10 feet. So here's your 10-foot base and your 8-foot base. And then the height, we'll say, is 3 feet. Remember that whenever you do these, the two bases are the two parallel sides, and the height must be perpendicular to the base. Now to find the area. Remember the area formula for a trapezoid is a little bit strange. It's the 1/2 small base plus big base. Now, these two don't really matter which one you call which, times the height. So I have 1/2. One base was 10 feet, one base was 8 feet, and the height was 3 feet. When I do that, I get 1/2 times 18, remember parentheses come first, times 3, and now I can just multiply. 1/2 times 18 is 9, 9 times 3 is 27 feet squared. Last example, find the area of a parallelogram with base 5.4 inches and height 3.6 inches. So remember, a parallelogram has two pairs of parallel sides, and the height needs to be perpendicular to the base with this 3.6 inches. Now, you probably don't need the picture for all of these, but it helps us to see what's going on. The area of the parallelogram is simply base times height. The base is 5.4 inches, the height is 3.6 inches, and I get 19.44 inches squared. Next example. Now we're going to look at some pictures that don't fit into a standard formula, but it's easy enough to adapt them to the formulas that we do have. Find the area of the figure to the right. This is the same semicircle area that we had in the previous lesson, but we didn't do area in that problem, we did perimeter. So if you'll notice, this is just another half of a circle. With it being half of a circle, notice that I'm given a diameter of 12 feet, and because I'm doing area, that means I need to know the radius is 6 feet. Now again, this is half of a circle. So when I do the area, I'm going to do 1/2. Just like I did with the curved portion with the perimeter, and I used a circumference formula but did 1/2 of it, now I'm going to do 1/2 of an area formula, pi r squared. So I get 1/2. I'm going to use 3.14 again. The radius is 6, and that's squared. I get 56.52 feet squared. Now when we did perimeter, we needed to do more at this point. We took the length of a curved portion, and then we had to add on this length right here. However, with area, it's just a matter of that's the space inside half of the circle. So it's one step for area with problems like this. There are some exceptions, and I'll show you at least one. Find the area of the figure to the right. Assume all angles are right angles. What we need to do for this one is somehow break it up into pieces. I think the easiest places to break would be to cut it up right here and right here to get two regions, which I'll just call 1, 2, and 3. It's 3 rectangles, despite my lines not being super straight. Let's find the area of each figure. For figure 1, that's a rectangle, and its area is length times width. We've got 3 centimeters by 10 centimeters to get 30 centimeters squared. Now for the second one, I am missing some information. This length right here is 2 centimeters. This length is not given to me, but it's pretty easy to find. Notice that this length right here is 16 centimeters, and this length is 10 centimeters. So therefore, we must have that this length is 6 centimeters in order for the 6 plus 10 to add up to 16. With that said, for region 2, the area would then be 6 centimeters by 2 centimeters, which is 12 centimeters squared. And for region 3, it's already given to us. This would be 16 by 4, which is 64 centimeters squared. Now, whenever you break up an area problem like this into pieces, at the end what we'll do is add them together. So our total area is 30 plus 12 plus 64, which is equal to 106 centimeters squared. For our final question, let's go back to the question I asked at the beginning of this lesson. Are all area units square units? If you came up with this one, then you realize that the answer is no. An acre is an example of an area unit that is not a square unit. It's usually used to measure land and land sizes. There is one given in the metric system called hectares, which is usually its most common one. It's kind of similar in size to the acre. But the acre is one of our standard units. It's a very strange number, though. It's defined to be 43,560 feet squared. And this number is somewhat arbitrarily picked, but originally an acre was designed to be the amount of land one horse could plow in one day. And this is just what we found to standardize it within reason. So let's do one example of this. Let's figure out the number of acres of a rectangular piece of property and the sizes of this thing. It's a rectangular piece of property. We've got 470 feet by 391 feet. If we're going to find the number of acres, what we should do first is just find the area in square feet, and then we'll make a conversion. The area of this figure would be 470 times 391, and I get 183,770 square feet. Again, we're not really interested in giving a square foot answer. We're asked to give the number of acres. So now we need to make a conversion. To make that conversion, we'll take this number that we just found and divide it by the conversion value of 43,560 square feet in 1 acre. And by doing this division, we will get an answer in acres. I get roughly 4.22 acres.